Question 11. The frequency distribution table shows the marks obtained by 100 students in a mathematics test. You have the table with the marks in percentage and their respective frequencies. From 1 to 10, frequency is 2. From 11 to 20, frequency is 3, and so on. A part of the question: draw a cumulative frequency curve for the distribution. B part: use the graph to find Roman figure 1, the 60th percentile. Roman figure 2, probability that a student passed the test if the pass mark was fixed at 35%. Solution: to construct the cumulative frequency curve, we need to construct cumulative frequency table from the given table by addition of two other columns: cumulative frequency and class boundary. Cumulative frequency is obtained from frequency starting with the first frequency 2. You add to the second 3, you have 5. You add 5 to the next one 5, you have 10. Plus 13, you have 23. Plus 19, you have 42. Plus 31, you have 72. 73 plus 13, you have 86. Plus 9, you have 95. Plus 4, you have 99. Plus 1, you have 100. To get the class boundary, what we need first is the boundary value, and boundary value is difference in adjacent side divided by 2. You get that from the class interval. 11 to 10 is one adjacent side, the difference is 1. 21 to 20 is another adjacent side, the difference is also 1. Divide 1 by 2, you have 0.5. To get the lower class boundary, you subtract the boundary value 0.5 from the lower class limit. So 1 minus 0.5, you have 0.5. 11 minus 0.5, you have 10.5, and so on. To get the upper class boundary, you add the boundary value to the upper class limit. So 10 plus 0.5, you have 10.5. 40 plus 0.5, you have 40.5, and so on. To plot the cumulative curve, all we need is cumulative frequency against upper class boundary. Just this part alone is what we need. Let us get that and plot the curve. As I said earlier, to plot the curve, all we need is cumulative frequency against upper class boundary. The vertical axis is for cumulative frequency and horizontal axis is for upper class boundary. On the vertical axis, the scale is 1 centimeter to 5 units, or 2 centimeters to 10 units. On the upper class boundary axis, no special scale is needed. From the origin to the end of the first box is the first upper class boundary, and so on. If you observe very well, the difference between the upper class boundary is 10, 10. So if we have 5 lines here, that means one line is 2. From 10.5, you have 12.5, 14.5, 16.5, 18.5, and 20.5. Alright, on the vertical axis, one line is simply 1 unit. So you have 2 from 0, you count 2, so this is 2 against 10.5. You have 5 against 20.5. You have 10 against 30.5. You have 23. After 20, you count 3 lines up, that is 23 against 40.5. 42. After 40, you count 2 lines up, that is 42 against 50.5. The next one is 73. After 70, you count 3 lines up against 60.5. You have 86. After 80, you count 6 lines upward, and you have it at that point. Then you have 95. After 90, you count 5 lines upward. Next is 99, and you have 100 against their respective upper class boundary. Next thing is to join the various points together. What you must note is that the shape of this curve is always S. You can already see it from the plotting of the various points. All the points have been joined together. You can see the S shape clearly. So let's move to B part of the question. You should obtain the 60th percentile. 60th percentile is 60 over 100. 60 over 100 times 100. The entire distribution is 100. That is the total cumulative frequency. So the 60th percentile simply means 60% of the entire distribution. That is 60 over 100 times 100, and you have the 60th position of cumulative frequency. From the curve, you locate 60 on the vertical axis, you trace it to the curve, and you trace down to the upper class boundary axis, and at that point you have 56.5. I've told us before that one line is 2, so from 50.5 you have 52.5, 54.5, 56.5. Roman figure 2, we should find the probability that a student passed the test if the pass mark was fixed at 35%. Now let's come here. A student who passed scored 35% and above. The exact number cannot be obtained from the table because of this class interval. Those that scored 31 to 40 are in that place, and we need 35 and above. You have to obtain that number from the graph. So somewhere here is 30%. So you trace 30% to meet the curve, and you trace to the cumulative frequency axis, and that is 15. So student who scored below, what you have done, I can see now, from 30 to the left, student that scored below 30%, they are 15. The entire distribution is 100. So those that score above 35% is simply 100 minus 15, and that is 85. Once you get for those that score below 35, you subtract it from the whole distribution of 100, that gives 85. So the required probability is 85 over total students 100, and that is 0.85. 0.85. Peter calls simplified maths. If you are watching and viewing from YouTube, don't forget to subscribe for more updates, like and share PSF videos. If you are watching and viewing from Facebook, follow and like the page for more updates. Also share PSM videos.